Hello, check. All right, people, I believe we are live. Welcome to Catalysis by Vedanto. If I'm audible and visible, please write you in the chat box. You know the drill. Yes, let me check the focus on the screen. And welcome to the episode 2, lecture 2, whatever you want to call it, for the Let's Revit series. And the question that's on your screen, of which the focus I'm setting, is the homework question that I had given you in the previous class. तो लास्ट क्लास का ये होमवर्क क्वेश्चन है. विदाउट एनी फर्दर डिले लेट्स गेट इनटू इट. या सो व्हाट्स गोइंग ऑन ओवर हियर? द HOH बॉन्ड एंगल इन वाटर मॉलिक्यूल इज 105 डिग्रीज. सो व्हाट्स हैपनिंग ओवर हियर? कुछ ऐसा हो रहा है यहाँ पे. 105 बनाना है, चलो बड़ा सा बनाते हैं कुछ फिर ऐसा. या हाइड्रोजन एंड इट्स गिवन दैट द एंगल इज 105 डिग्रीज. या सो माय डियर फ्रेंड्स, व्हाट आर द टू वेक्टर्स ओवर हियर? क्या दे रखा है? डाइपोल मोमेंट फॉर द एंटायर मॉलिक्यूल इज 1.85 d by. Yeah, so the total dipole moment is equal to 1.85 d by. Right now the thing is that this total dipole moment is a resultant of the individual dipole moments, है ना. एक dipole moment इस डायरेक्शन में है, एक dipole moment इस डायरेक्शन में है. So when we add up these two dipole moments, then you get total dipole moment equal to 1.85 d by. So if this is A and this is vector B, my dear friends, what's the resultant vector equal to? The magnitude of the resultant vector, mu total, will be equal to root of A square plus B square plus 2AB cos theta. Do you remember this formula? Very simple formula from basic mathematics, basic physics, whatever you want to call it. Yeah. तो यहाँ पे क्या आ जाएगा? Since A and B are equal, yeah. Since A and B are equal, let's just call them A. दोनों को A बोल देते हैं. Yeah. So this becomes 2A square plus 2A square cos theta. I mean, there are better ways of doing it. You can take individual components, add them up. Same thing will happen. Yeah. But ऐसे भी करना तो चलेगा. ठीक है, फाइन. इफ आई हैव डन एनी मिस्टेक इन द फॉर्मूला, प्लीज करेक्ट मी. माय मैथमेटिक्स माइट गो रॉन्ग समवेयर. ठीक है, तो मैंने कहीं मैथमेटिक्स में गलती कर दी हो तो प्लीज करेक्ट मी. या बट आई होप यू अंडरस्टैंड व्हाट आई एम ट्राइंग टू डू. आई एम जस्ट टेकिंग द रिजल्टेंट वेक्टर टू फाइंड आउट द इंडिविजुअल कंपोनेंट्स. ठीक है, तो इसको मैं कैसे लिख सकता हूं? लेट्स जस्ट टेक आउट 2A स्क्वायर कॉमन. दिस इज 1 प्लस cos theta. Cos theta is already given as 0.259, है ना. तो यहां पे आ जाएगा 0.259. This is your 1.85 d by. Yes. So just do the calculation. How much does this come out to be? How much does this A come out to be? कितना आ जाता है ये? Single mu. Yeah, I'm pretty sure you have calculated. Siddharth, welcome to the classes, man, but you don't really need to study right now. You can study later as well if you're preparing for JEE 2024. Okay. चलो ये देख लो. बताओ क्या आ जाएगी A की वैल्यू? कितना आ जाएगा? All of you who have solved it, there are a bunch of people who've solved this correctly in the previous class. तो A कितना आ जाएगा यहाँ पे? What's the value of one particular dipole? And in the examination, of course, calculation is not allowed, but this is a very advanced question. You can try using the calculator just for this question if you want to. I would suggest against it, but try करना तो करके देख सकते हो. बताओ. कोई नहीं बता रहा. क्या हो गया भाई? सोने आए हो क्या? Are you here to... Rohan bro, I mean, let's not worry about what the actual value of the cos will be. This is what matters to us. ठीक है, ये ज़्यादा मतलब जो वैल्यू दिया वो लेके चलेंगे आगे. So Swati is saying it will be 1.52. अच्छा, Mandy is also saying 1.52. Interesting. Anyone else? I don't see the regular people over here. क्या हो गया भाई? सो तो नहीं गया आज? क्या हुआ? Yeah. So this single dipole moment. Okay, the single dipole moment, if you calculate it properly, it comes out to be 1.52. Okay, single dipole moment जो है आपका, it comes out to be 1.52. Okay, so this is 1.52 d by. Now d by, if you know the units properly, you would realize that it can be calculated into electrostatic units per stick to electrostatics units into centimeters, yeah. So I can simply write this as, if you know the conversion, it's very simple. This can be written as 1.52 into 10 to the power minus 18 electrostatic units into centimeters. Okay, this is the conversion factor that you can keep in your mind. Again, hardly do questions like this come in the examination. This was just a brain teaser for you. So ye aa jayega. Now my dear friends, this 1.52 is for one specific dipole, isn't it? है ना जी? This is for one specific dipole, and what is given to us is 0.94 angstroms is given. Yeah, so can I say that this A is equal to Q times D? Q will be the charge on one atom, D will be the distance. D is given to you as 0.94 angstroms. Can I write it as 0.94 into 10 to the power minus 8 centimeters? Of course I can write it like this, isn't it? Why centimeters? Because A is in ESU into centimeters. So this comes out to be 1.52 into 10 to the power minus 18 ESU into centimeter is equal to charge on hydrogen, charge on oxygen times this. यहाँ से ये कट के 10 रह जाएगा. Cool, people. This is something that you will get. Okay. So यहाँ से कितना आ जाएगा? That Q is approximately equal to 0.94 है ना ये. So Q 1.52 divided by 0.94, little more than 1.5. So Q will be approximately 1.6 into 10 to the power minus 10 ESU. This is the charge. But this is not the complete answer right now. Think about the water molecule. This is the oxygen, this is the hydrogen, this is the hydrogen. What it means is that one dipole, okay, in just one dipole, you will have plus 1.6 into 10 to the power minus 10 ESU plus this will be minus 1.6 into 10 to the power minus 10 ESU. Okay, this will be plus 1.6 into 10 to the power minus 10, and because of this hydrogen, the oxygen will have another minus 1.6 into 10 to the power minus 10. So when you add both of these values together, that is when you will get your final answer. The answer finally will be approximately 3.2 into 10 to the power minus 10 electrostatic units of charge. Okay, ठीक है. So total answer आना चाहिए आपका 3.2 approximately. So the exact procedure I have told you: take the resultant, I mean this is the resultant dipole, calculate the single dipole. Single dipole is charge into distance. Distance is given, calculate the charge. Double of that will be on oxygen. So let us see how many people gave me the correct answer. There were very few comments on the previous class. तो चलो देखते हैं किस किस ने सही आंसर दिया. Just give me one moment. I am opening the previous class. Yeah. तो क्लास तो मैंने खोल दी. Just have a look at this. ये थी. हाँ. Okay. So this was your Take 5 episode 1, and let's sort the comment by newest first. Let's see at the bottom. Chalo bhi. Okay, Shivam, bro, what units are you talking about? I have no idea. Sorry. Kratika, yes, correct. And very good job. Rajita, okay, good job. Saroj, very nice. Bharat and Atharv, please mention the units as well, but correct answer. Yuvraj, very good job. Shivam, bro, again, you did not have to take only the resultant dipole. You had to take individual dipoles and then calculate the charge on oxygen. See, I hope you understand that in the resultant dipole, some component of it is being added, some component of it is being subtracted. Do you understand that if one dipole is this, one dipole is this? Can you see the tiny little image on the screen? Yeah, नहीं दिख रहा होगा, चलो बड़ा कर देता हूँ. Yeah, if this is what's happening, the resultant dipole is a combination of addition of these two vectors and a subtraction of these two components of the vectors. Yeah, so you can't simply take the resultant dipole to take the charge on oxygen. You have to compute you have to compute the individual dipole and then use that to calculate the charge on the oxygen. So that's what the catch was over here. You couldn't simply take the overall dipole. ठीक है, रुको बाकी लोगों के भी नाम देखते हैं. या सो ऋषिका करेक्ट, दिविष्टा वेरी नाइस जॉब, साइंस प्रिया गुड जॉब, स्वाति वेरी नाइस, Surya, good. Nayantara, I am not sure about the charge in coulombs, but I think it should be correct if you followed the same methodology. ठीक है, बाकी मेरे को किसी का दिख नहीं रहा. Tony and Nayantara, let me check. Have you given the same answer? दोनों का अलग आंसर है. Please check if your answer is correct or not. Tejasvi, yeah, correct. And Sanjeet, very good job. Ashutosh, I hope now you understand what is the correct way to approach this question. Chalo ji, I think we have taken the names of almost everyone who's given the correct answer. Understood? Fine. Let's move on to the next question now. Before the next question, I want to make an announcement that on the 28th of August at 7 p.m, in case you have time, I know your examination is very close right now. So in case you have time on Friday at 7 p.m, if you want to attend this very interesting session, Learn the Art of Winning with PV Sindhu, again, a very inspirational personality. So you can enroll for this particular session. The link will be in the description box down below. You can check it out. Let's move on. Chalo ji. Now, this is the question. You can call it question number 1 or question number 2. I don't know, whatever you want to call it. Par chalo. So this is also a passage type question. We have a passage that is given and then you have 1, 2 and 3 questions related to the same passage. Yeah, so it's a comprehension type question. It's from the chapter of Thermodynamics. Let's read the passage, which is sort of useless, and then we'll read the question itself. Cool. तो चलो करके देखते हैं what's going on over here. The first law of thermodynamics was given as Q equal to U plus minus W, where Q is the heat, U represents increase in internal energy, ये वो. Some processes, some results. The molar heat capacity for 1 mole of monatomic gases 3/2 R at constant volume and 5/2 R at constant pressure. ठीक है, तो यहां से there is one result that we can remind ourselves of, and that is Cp minus Cv is equal to R. What is Cp? Molar heat capacity at constant pressure. Cv is molar heat capacity at constant volume. These are molar heat capacities. Remember that idea. ठीक है, molar heat capacities. Now, let us try to read the question that is given next to it. Question visible है ना? I think it is visible. I'll increase the size of the question if you want. It's a little blurred because I've taken a screenshot. But chalo, increase the size a little. It'll be a little more big and visible right now. Chalo, which of the following statements are correct? First statement is both work and heat appear at the boundaries of the system. Do you understand the meaning of this statement? Let me try to explain it to you. Let's say this is my system. If I am doing work on the system, do you realize I will have to compress the boundaries of the system? Because when I do work on the boundaries of the system, it gets translated into the internal energy of the system. It gets converted into, let's say, the kinetic energy of the gaseous particles. तो जब भी मैं बाउंड्री पे कुछ काम करता हूं ना, वो अंदर जाके कन्वर्ट हो जाती है. If I'm working on the boundary, when it goes inside, it turns itself into some other form of energy. Yeah. So if I'm giving heat, the heat is being given on the boundary. You can imagine if this is the boundary of the system, I have put like a flame over here. Yeah. Once the heat goes inside the system, it is translated, it is converted into its internal energy. Isn't it? It is converted into its internal energy. So heat and work only appear on the boundaries of the system. They are also known as boundary phenomena. Okay, so heat and work exchange happens only on the boundaries. This point is correct. Then the second point is heat given to a system is a positive sign. Do you agree with me? When I give heat to the system, I am increasing the internal energy of the system. So that is why heat given to the system, it is a positive sign. This is a relatively simple question. The next question is a little more difficult one. So the third statement says heat given to a system is equal to increase in internal energy under isothermal conditions. My dear friends, in isothermal conditions, do you realize that delta T is equal to 0? If temperature is not changing, do you realize that for an ideal gas process which is given to us over here, for an ideal gas system, delta U will also be equal to 0. If you are giving heat to that system, since you have to maintain the temperature, you will have to take out some work from that particular system. Yeah. So since it is an isothermal system, your change in internal energy will be 0. ठीक है. So heat given to a system is equal to increase in internal energy? Definitely not. Option number 3 is incorrect. Option number 4, heat given to a system is used to increase internal energy under isochoric conditions. This is correct. Do you remember delta U is equal to your Q plus W, and how can we write W? W can be written as minus P dV. Now if your dV is 0, if your change in volume is 0, that is an isochoric process, so delta U comes out to be QV. So this is a good way to revise our concepts as well. We also write it as NCV delta T. Yes, ठीक है ना. तो दोस्तों यहां से क्या आ जाएगा, हीट गिवन टू अ सिस्टम इज यूज्ड टू इंक्रीज इंटरनल एनर्जी इन आइसोकोरिक कंडीशंस. करेक्ट. Then this one is saying both work and heat are not state functions, but their sum is a state function. Absolutely correct. The work and heat are path functions, depend on the path taken, but overall when you add them up, it is change in internal energy, which is just a state function. So statement 1, 2, 4 and 5 are correct. Option number A is correct. Simple question, just helps us revise a bunch of things from the thermo chapter. Now the next question is a little more entertaining. This particular question, let me try to increase the size of this guy as well. इसका भी थोड़ा size increase करते हैं अपन. अरे यार, चलो, let's see now. A system is allowed to move from state A to B following path ACB, absorbing 80 joules of heat energy. The work done by the system, the work that is removed from the system, is 30 joules. So my dear friends, can I say that when I'm going from A to C to B, can I say over here that delta U is equal to 50 joules? 80 joules is absorbed, 30 joules is released. Okay. The work done by the system in reaching B from A is 10 joule through path A, D and B. तो अगर मैं यहाँ से जा रहा हूँ, okay, if I am going from that path, this is your point D. यहाँ पे क्या दिया है, that your W is equal to minus 10 joules. Why minus 10? Because in chemistry's convention, whenever the system does the work, we put a negative sign next to it. Yeah. So over here, 10 joules is done by the system. That is why in chemistry's convention, work is minus 10 joule. Okay? So since I am overall going from point A to point B, no matter what path I choose, since internal energy is a state function, do you realize that over here I can say that delta U will be equal to 60 joules? Because overall when I add up, delta U has to be equal to 50 joule. ठीक है ना? चलो ये हो गया. So first thing is increase in internal energy from state A to state B is 50 joule. Absolutely correct option. Second statement says if path ADB is followed, to reach state B, delta U is equal to 50 joule. That is also correct. Option number 1, option number 2 are correct. Third says if work done by the system in path AB, okay, if work done by the system in path AB is 20 joule, work done by the system is releasing heat. The heat absorbed during the path is 70 joule. 70 minus 20 is 50. So this is also correct option. Next option is the value of UC minus UA is equal to UD minus UB. This is a good option. This is an interesting option. Yeah. So what's going on over here? Let's try to figure out. देखो पूछा क्या है? Internal energy C minus internal energy A. देखो. So this is your C, A, B, D. In A to C, yeah, what is this process? UC minus UA. So I am going from A to C. C is final, A is initial, final minus initial, है ना? So I am going from A to C. What is the delta U in this process? Is this delta U the same as this delta U? Let's call this delta U1, let's call this delta U2. Is that the same value? I am pretty sure you can understand that the value is not the same. Can you see? Simple way to think about it is, this is your PV diagram. Volume is constant. So since volume is constant, If I increase the pressure, my temperature is increasing. So from going from A to C, my temperature is increasing. So internal energy will also increase. Over here, when I am going from B to D, pressure is decreasing. So temperature is decreasing. So I can say that internal energy will also be decreasing. So this energy, this delta U will be a negative sign, this delta U will be a positive sign. Okay, signs are different, so the values are different. But my question to you is, are their magnitudes same? Are their magnitudes same? Absolute value जो भी है, I am not the absolute value, I mean the exact value is different, but are their magnitudes the same? Think about it. क्या सोचते हो? Are their magnitudes the same? Interesting, right? You can assume values. चलो values assume कर लो. Let's say this is 1 atm. Yeah, this is 2 atm. You don't know what the volume is over here. You don't know what the volume is over here. You just know that these processes, this process and this process, are isochoric processes. Yeah. So there will be some temperature over here, T1. If you know T1, then you can calculate T2. If you know TB, then you can calculate TD. Yeah. Because for both of these processes, my P by T will be a constant value. Isn't it? Because volume is constant for both of these processes. So P by T will be a constant value for both of these processes. Once you calculate these individual temperatures, are the differences in temperature the same? सोच के देखो. This is chemistry class, Jatin. Yes. You think about it. Their delta T's are different. Okay, you can take values if you want. You can assume specific values if you want. You will realize that the delta T's are different. Even though P1 by T1 is equal to P2 by T2, जो भी करना है कर सकते हो. Even though both the processes are isochoric, even though delta P is the same, you will realize that the delta T can still be different. Okay, delta T can still be different. So my dear friends, this particular statement is incorrect. You can experiment with it all you want. Last statement says heat absorbed by the system to reach B from A through AdB is 60 joules. We had already calculated that. So this statement is correct. 1, 2, 3 and 5 are correct. Option number C is the correct one over here. Nice question. Now the next question is the best question from this particular passage. Look at this. 1 mole of a monoatomic gas is expanded through path ABC as shown in the figure. Now this path might not be very visible, so I'll draw the path over here. So there is a PV diagram. ठीक है, ये है pressure, ये है volume. What are the points that are mentioned? There is a point where pressure is 0.5 atm. There is another point where pressure is 1 atm. Okay. कुछ ऐसा कर दिया यहाँ पे. Now the first volume that is mentioned over here, वहाँ पे ग्राफ में it's not written, but it is 22.4 liters. There's no other way to decipher it. It should have been written over here. That's a misprint on the graph. And then you have your 44.8 liters. ठीक है. So this is what's going on. This is the kind of graph that we have. Cool. Fine. And this is point A, this is point B, and this is point C. Arrows are drawn like this. ठीक है? चलो. अब the first statement, I mean it's an incomplete statement. I'll tell you what it means. If specific heat of gas are 0.125 and 0.075 calories per gram, the molecular weight of gas is 40. ये क्या हो गया भैया? What is this now? ये क्या है? What is this going on? I'll tell you what it means. Okay, this is the graph. I'll tell you the meaning of the first statement. The first statement is very interesting. Let's try to understand it. Let's try to do some mathematics to satisfy the curiosity for the first statement. देखो. Specific heat. Do you understand the difference between specific heat and molar heat? Do you understand the difference between specific heat and molar heat? Yeah. For molar heat, heat is equal to N into the molar heat capacity into delta T. But if I want to write it in specific heat, what does that imply? Molar heat capacity is the heat required to raise the temperature of the system by 1 Kelvin. Okay? ठीक है? Molar heat capacity is temperature required, the heat required to raise the temperature of the system by 1 Kelvin in terms of number of moles. Okay, molar heat capacity, you are raising the temperature of 1 mole of the system. This is C molar. But do you realize I can also write given weight? Okay, let's say there's some weight into specific heat capacity into delta T. Do you understand what I've written? Heat can be written as N into Cm delta T, molar heat capacity, or weight of the entire system into specific heat capacity into delta T. Specific heat capacity is the heat required to raise the temperature of the system by 1 Kelvin. What system? 1 gram. Specific heat capacity is heat required to raise the temperature of 1 gram of the system. So molar heat capacity, specific heat capacity, this is what I can write. Yeah. Now total weight divided by number of moles can be written as what? Yeah. Do you remember this? That number of moles is equal to given weight upon molecular weight. So from here, can I write that molecular weight is equal to given weight upon number of moles? Number of moles is equal to given weight upon molecular weight. Ulta kiya, molecular weight is equal to given weight upon number of moles. So my dear friends, do the manipulation over here. Do the manipulation over here. Can I say from here that C molar is equal to, okay, C molar is equal to molecular weight multiplied by C specific? Thing that I can write. Now my dear friends, this heat capacity is specific heat capacity at constant pressure. This heat capacity is specific heat capacity for constant volume. Now can you verify the first statement please? Can you verify the first statement please? सोच के देखो. This is CS at constant pressure, CS at constant volume. And this is the relationship over here. Okay, चलो मैं दोबारा से थोड़ा और हेल्प कर देता हूं आपको. Let me help you guys a little bit. Do you remember that Cp minus Cv is equal to R, and these were molar heat capacities. Yeah, these were molar heat capacities. Now if I want to write these individuals into specific heat capacities, what will I do? Molecular weight into specific heat capacity at constant pressure, जो नोटेशन यहां लिखी है वही यूज करते हैं. Specific heat capacity at constant pressure minus molecular weight into specific heat capacity at constant volume is equal to R. Can I write that? Do you understand? This is a result that we just derived on this part of the page 1 minute back. Yeah. Molar heat capacity is equal to molecular weight into specific heat capacity. So can I rewrite this in a little better manner? Can I write this entire thing as लिख सकता हूं ना, R अपॉन मोलिकुलर वेट. मेरी हैंड राइटिंग बहुत घटिया, सॉरी. या specific heat capacity at constant pressure given as 0.125 minus specific heat capacity at constant volume given at 0.075. Look at the units now. Look at the units now. Calories per gram. My dear friends, what are the units of R in calories? R is equal to 2 calories per mole Kelvin. Do you remember? R is equal to 2 calorie per mole Kelvin. तो यहाँ पे मैं लिख दूंगा 2 by x. X is what you have to calculate. बताओ x क्या आ जाएगा? कितना बच गया? 0.05. 2 by 0.05 आ गया. X is equal to 40. चलो जी. Yeah. First statement is correct. Very nice. First statement is correct. Just a bunch of manipulations to verify the first statement. Instead of giving you molar heat capacities, they've given you specific heat capacities at constant pressure and constant volume, and the relation between specific and molar heat capacity we just learnt over here. ठीक है, तो 40 तो आ गया अपना. Very nice. Now the next thing is temperature at point A, B and C are 273, 546 and 273 respectively. This is very easy to see. देखो दोस्तों, do you remember this result that 1 mole gas, okay, at standard temperature and pressure is equal to 22.4 liter? Do you remember this result? 1 mole of monatomic gas is taken. Okay, so 1 mole of gas at standard temperature and pressure is equal to 22.4 liter. अच्छा, ये 1 atm 22.4 liter, 1 mole, so temperature will be 273 Kelvin. Standard temperature and pressure, so no need to solve it, you know the result already. Now if I am keeping the pressure constant, volume is doubled, pressure will be doubled, 22.4 से 44.8 liter, so temperature will be doubled. Temperature doubled is how much? 546 Kelvin. If I am reducing the pressure but I am not changing the volume, pressure is halved, temperature will be halved, so this is also 273 Kelvin. The second step is very easy. The first one was a little difficult, second part is very easy. So option number 1 and 2 are correct. Do you see option number 5 is incorrect? Let's deal with option 3 and 4 in a little while, but do you see option number 5 is incorrect? Delta U for the overall cycle ABC back to A is 3.4. nahi. If you are coming back to the same point, internal energy changes 0. Internal energy is a path function. Change in internal energy will be 0 if you come back to the same state. Option number 5 is incorrect. So now we need to see whether 3 and 4 are correct or not. ठीक है, तो ये अपने पास ग्राफ बन चुका है. दिस इज द ग्राफ दैट वी हैव. आई नो आवर हैंड राइटिंग, माई हैंड राइटिंग इज नॉट वेरी गुड, बट आई स्टिल थिंक यू कैन रीड व्हाट्स गोइंग ऑन. So first thing is delta U for the process A to B is given as. अच्छा, सोच के देखते हैं इसको. This is a good question. Delta U for the process A to B. How do we figure that out? My dear friends, this is a constant pressure process, है ना? तो delta U is equal to Q plus W. Can I write it like that? क्या यहां से कुछ निकाल सकता हूं मैं? Can I figure out something from this idea? Doesn't really make sense. Can I do something like NCV delta T? बताओ. What method should I use in order to calculate the delta U for the process where you are changing your temperature from 273 to 546 Kelvin? ओके, एनसीवी डेल्टा टी की जगह आप ये भी यूज कर सकते हो, m इंटू सीवी सी स्पेसिफिक इंटू क्या कहते हैं यहां पे, अरे यार एक सेकेंड ना, सी स्पेसिफिक एट कांस्टेंट प्रेशर, सॉरी कांस्टेंट वॉल्यूम इंटू डेल्टा टी. दैट इज समथिंग दैट यू कैन ट्राई टू डू, है ना. डेल्टा एच रिलेशन से कैसे करेंगे नयनतारा? दैट इज आई डोंट थिंक दैट इज गोइंग टू बी इजी टू डू. आई थिंक दिस वुड गिव अस अ गुड आंसर. दिस इज व्हाट आई थिंक शुड गिव अस द करेक्ट आंसर. बाकी लग जाएगा पता, मतलब अगर ये सही आंसर नहीं दिया इसने तो, या बिकॉज योर टेम्परेचर इज बीइंग डबल्ड ओवर हियर. सो should we be able to calculate it like this? कर सकते हैं क्या? ट्राई करो. डज दिस वर्क? Ayush is saying P into V2 minus V1. कैसे? How can you say that heat is zero in this process from A to B? Ayush is saying simply do P into V2 minus V1. अच्छा, अगर मैं करूं वैसा तो how can you assure that heat is zero? Because W is P delta V. Okay, great. But what about Q? हाँ अक्षय, एनसीवी डेल्टा टी ही लिखा मैंने यहां पे दोस्त। बताओ बताओ बताओ। नहीं 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 नहीं, विभूति एट एनी पॉइंट ऑफ टाइम एनसीपी डेल्टा टी इज चेंज इन एंथैल्पी, एट एनी पॉइंट ऑफ टाइम एनसीवी डेल्टा टी इज चेंज इन internal energy. Now since it's just a path function, yeah, we are just going from point A to point B, it is just a path function. Okay, so path function, I mean sorry, क्या बोल रहा हूँ मैं, internal energy is just a state function. Do you understand? State A and state B is what matters to me. How I went through that state does not really matter to me at all. ठीक है, मैं यहां से यहां किस तरह से गया वो मैटर नहीं करता, मैं यहां से यहां गया, so my temperature is different. यहाँ 546 है, यहाँ 273 है. What is the formula that we have for delta U? NCV delta T or mass into specific heat capacity at constant volume into delta T. So try this out. Does this give you the correct answer? करके देखो. Try करके देखते हैं. Let's figure it out. So the answer will be 40 into कितनी दे रखी है? 0.075 इंटू डेल्टा टी कितना है? 273. ठीक है, एंड यू हैव टू कन्वर्ट इट इनटू जूल्स. रितेश सिंह, डेल्टा यू फॉर कंप्लीट साइकिल इज 0. हाँ दैट इज करेक्ट, वो तो कोई प्रॉब्लम नहीं है. हाँ कृतिका, दैट इज करेक्ट. एनसीवी डेल्टा टी विल बी यूज फॉर प्रोसेस बी टू सी. तो चलो प्रोसेस बी टू सी थोड़ा इजी है, वो कर लो अगर करना है तो. या वी विल थिंक अबाउट द प्रोसेस ए टू बी. Okay, just give me one moment. We'll think about this process as well. For process B to C, it's very simple. Okay. For process B to C, the answer is very simple. Process B to C is already a constant volume process. Yeah, this is a constant volume process. Yeah, so यहाँ पे I can simply use the formula delta U is equal to NCV delta T, or I can also write it as mass into specific heat capacity at constant volume into delta T. What is the answer that we'll get over here? Mass is 40 grams. Okay, into what was the heat capacity? 0.075 है ना जी. This is given into delta T. Delta T कितना आ गया यहाँ पे? 273. We're just calculating the magnitude. We're just calculating the magnitude over here. So this will be the answer in calories. Yeah. So if you want to convert it into joules, then you have to multiply this into 4.2 as well. So joules में answer आ जाएगा. So how much does this come out to be? This calculation comes out to be 3440 approximately. ये calculation करके देख सकते हो आप. 3440 joules. So this particular point is absolutely correct. Point number 4 is correct. ठीक है. Point number 4 is definitely correct. My question to you now is, how do we calculate the delta U for the process A to B? उसका delta U कैसे calculate करें? That is my question to you. बताओ. Can you guys suggest? हाँ मतलब टोनी आर्या, काफी सही जगह जा रहे हो आप. Yes, Amar, absolutely correct. 3439. Anirudh, देखो, this is just a constant volume process over here. Yeah, delta U is equal to Q plus W. Work done is 0 in this process because it's a constant volume process. P delta V में delta V 0 है. So simply the heat exchange in this process is equal to the internal energy change. Heat exchange in this process is equal to NCV delta T, or mass into molar heat capacity at constant volume into delta T. That is what we have done. So for AB, what you are suggesting is, AB के लिए आप suggest कर रहे हो that I can say delta U is equal to Q plus W. अब Q क्या आ जाएगा यहाँ पे? What are you saying? Q आ जाएगा यहां पे N इंटू CP इंटू डेल्टा T. यही बोल रहे हो ना? N into Cp into delta T, because this is a constant pressure process. Cp is given, Ncp delta T. We can calculate the Q minus P delta V. Yeah, pressure is also given, volume change is also given to us. Yeah, so this is an expansion process. Since it's an expansion process, the work being done on the system is negative. So यहाँ पे आ जाएगा NCP delta T की जगह what we can do is mass into specific heat capacity at constant pressure into delta T. This will be a value in calories minus P delta V. If you do the same calculation from here, this will be in liter ATM. Subtract it. I think you should get the answer. है ना? This is what you are suggesting. I believe your method is absolutely correct. So करके देखो calculations थोड़ी. Let's try to do the calculations of this case. Okay, I'm removing the exact numbers from here. I am sure you remember them already. चलो तो करके देखते हैं. Mass is 40 into specific heat capacity is given as 0.125 into delta T is once again 273 Kelvin. है ना जी, क्योंकि इंक्रीज हो रहा है टेम्परेचर, सो हीट इज गिवन टू द सिस्टम, इंटरनल एनर्जी इज इंक्रीजिंग, एंड दिस इनटू 4.2, दिस विल बी जूल्स माइनस pressure is 1 atm, 22.4, this is liter atm. Yeah, so liter atm into 101 is joules. This is the calculation that you have to do. Figure out सही आ रहा है कि नहीं, करके देखो सही आ रहा है कि नहीं. I think it should be correct. Option number A should be the correct answer. इसे कैलकुलेशन करके देखते हैं 2 मिनट. अच्छा, और ये कितना आ जाएगा, रुको, 5733 माइनस आ रहा है क्या, सही आ रहा है क्या पीपल? आर वी गेटिंग 2.27? Mahima is saying 2270 आ रहा है आंसर. अच्छा, if you are saying that the answer is coming, then I will move forward. अगर आप बोल रहे हो कि आंसर सही आ रहा है तो मैं आगे बढ़ जाऊंगा. ठीक है क्या? ठीक है, people are saying that the answer is coming out to be 2270. Cool. So option number A is the correct answer. Great. Awesome. मौज हो गई भैया. Yeah. So you just have to do a little bit of an accurate calculation over here, joules, and this has to be converted into joules. तो बस वो थोड़ा सा ध्यान रखना है उसको convert करने में. Yeah. तो एक बार देख लो, in case you have any doubt, you can ask me. Rohan is saying, why is NCV delta T wrong? Because this is not a constant volume process. That's what, bro. That's the main problem over here. Okay. हाँ, आइडियल गैस तो है ही है, बट अगेन the points are different. Okay, so that's the thing. This point is different from this point, is different from this point, so the states are different. The best formula has to be used in each of the cases. Now this was simply a constant volume process, so we could directly use delta U is equal to delta CV. क्या बोल रहा हूँ मैं? You could simply use the idea that delta U is equal to QV, that is NCV delta T. But over here it's not a constant volume process, so that formula can't be used directly, because the heat exchange in this process is not equal to heat exchanged in constant volume process. Yeah, and heat itself is a path function. So you need to think of the heat in this process and the work in that process. Both of these are separately you can calculate them separately and then you can get the answer. हाँ, वही मैं पूछ रहा हूँ कि कैलकुलेशन में कुछ गलत है क्या यहाँ पे? Yeah, that's what I'm asking, क्योंकि मेरे को भी लग रहा है कैलकुलेशन में कुछ तो गड़बड़ है. So where are we going wrong? That is my question to you. है ना? क्योंकि सिर्फ P delta V अगर मैं कर रहा हूं, only P delta V is coming out to be that 2270 kilojoules, isn't it? Yeah. Do you realize only this is coming out to be 2270 kilojoules, but the heat of that process is also there. है ना? So total तो आ जा रहा है ये 3.4 kilojoule something, which is exactly what we got as तो कुछ तो गड़बड़ है यार यहाँ पे. Something is wrong with the question, I believe. 1 is correct, 2 is correct, 4 is correct, 3 I'm not sure it is correct. I think they should be asking W for the process A to B. If they ask what is the work done for the process A to B, then yes, this is correct. If they are asking delta U for the process, then something is definitely wrong. Okay? So, हाँ, बिल्कुल सही बोल रहे हो आप लोग. Even if you use the formula of delta U is equal to NCV delta T, or you do this weird jazz that we've done, same thing, answer will come out to be 3.4 kilojoules. Yeah, so yes, you can use the formula NCV delta T over here. The question confused us. If they are asking about work done over here, then yes, that work done is 2.27 kilojoules. So yeah, the question itself is a little incorrect. ठीक है? Oh. Akshay, because this is a chemistry class, bro. In chemistry, the convention of work done is minus P dV. Okay, this is chemistry that's going on. Physics में the convention of work is plus P dV. वहाँ पे कुछ और चलता है. Over here minus P dV. Chemistry में the law of thermodynamics is Q minus W. Over here it is Q plus W. So that is why things are a little different. Okay, people, is this clear now? Does this make sense now? If we take work done, then that will come out to be 2.27 kilojoules. If we have to calculate internal energy change, then internal energy change once again is proportional just to the temperature, and that has to be 3.4 itself. ठीक है? Cool. If there's anyone who has a confusion, tell me. काफी मजेदार question हो गया ये. Question itself was incorrect. चलो बढ़िया. Nice. Okay, let's move on to the next question now. Thermodynamics ने जान ले ली पूरी, but हाँ, काफी सही. Shreyas is saying, why is the convention in chemistry and physics different? Because different scientists worked on it. There's nothing too much to worry about. ठीक है? चलो बढ़िया. Prakhar, if you have a doubt in a specific point, please tell me. Otherwise, I believe we have spent too much time on one question only. Chalo, next question now. How many of the following compounds will show you stereoisomerism? Batao. How many of the following compounds will show you stereoisomerism? देखो, काफी simple सी बात है. My dear friends, when do you see geometrical isomerism in? Okay, I'll give you a hint of this idea. I've explained this in the optical isomers entire chapter. I'll give you the idea. When will this show geometrical isomerism? Will this structure show geometrical isomerism? Will this structure show geometrical isomerism? Yes or no? Yes, it will. Why? Because A is different from B, and on the other side A is different from B. So cis trans is possible over here. This guy will show geometrical isomerism. Will this guy show geometrical isomerism? This guy will not show geometrical isomerism because on the same side two things are same. So on one side both the things have to be different. That's the idea for geometrical isomerism. Okay. So the concept is that if this guy can show geometrical isomerism, add one more double bond in the middle. Okay. Now what's happening? On one side if you have A and B like this, on the other side do you realize you will have A and B like this? कुछ ऐसा हो जाएगा on the other side. These will be in the plane of your screen, these will be on the plane of your desk. Yeah, in the plane of your screen, in the plane of your desk, plane of screen, plane of desk, plane of screen, plane of desk. ठीक है? तो दोस्तों बात ऐसी है कि this guy will show optical isomerism. Okay, if one double bond shows geometrical isomerism, add one more double bond, it will show optical isomerism. If you have one more double bond, geometrical isomerism, one more double bond, optical isomerism. Keep on going in this fashion. Mic तो नहीं तोड़ दिया अपना? Just a second, let me check. Hello, yeah. The wire was stuck. Cool. So single double bond, only one double bond geometrical, two double bonds optical, three double bonds geometrical, four double bonds optical. The condition is the same. On one side, both the things should be different. On the other sides, both things should be different from each other. ठीक है? So people, what's going on over here? Can this show optical isomerism? No, because on one side both chlorines, on one side both bromines. Optical isomerism can't be shown. Over here, optical isomerism is possible. Chlorine and hydrogen different, bromine and hydrogen different. This will show optical isomerism, as I have explained over here. If you want to see the exact diagram, etc., etc., we've done it in mirror on the wall series in the beginning of the month of May. ठीक है? चलो ये हो गया. Then you have 2-butanol. 2-butanol very obviously is optically active. This is a chiral carbon, so yeah, this is correct. Does this have a chiral carbon? I can see that this is a very beautiful chiral carbon over here. This will show stereoisomerism. So 1, 2, 3 are there. Achha. This guy, how do we decipher this guy? My dear friends, this spiro compound is as good as this type of a compound. Okay, this entire square can be replaced by a double bond if you want to think about geometrical or optical isomerism. ठीक है, काफी simple सी बात है. Over here, the same orientation for the groups will be there when you compare it to a double bond. ठीक है, so one spiro is as good as one double bond. No need to worry about it. So ClBr, can this guy show optical isomerism? Yes. On one side both things are different, on the other side both things are different from each other. This will show optical isomerism. So 1, 2, 3, 4. This guy, my dear friends, do you realize this guy shows both geometrical and optical isomerism? There is a chiral center over here and there is a double bond across which the configuration can be different. So it shows not only optical isomerism, it shows geometrical isomerism as well. Two types of stereoisomerism. This one as well is going to be counted. So 1, 2, 3, 4 and 5 structures are there. What about the last one? Structure number 7. What about this guy? My dear friends, can you see a plane of symmetry? Can you see a very beautiful plane of symmetry in that structure? Let me try to show you the plane of symmetry. Yeah. Now can you see the plane of symmetry? Just cut it from the middle. Yeah. Keep these two like this. इसको बिल्कुल ऐसे रखो अगर. Yeah. Cut it from the middle. Can you see a plane of symmetry? Very beautiful plane of symmetry right in the middle. This is not optically active. There is no geometrical isomerism possible. It won't show stereoisomerism. So finally, 1, 2, 3, 4 and 5 structures will show you optical isomerism. If you guys have solved MS Chauhan, then this is an easy question. Yeah. If you guys have solved the MS Chauhan, तो फिर तो ये बहुत ही आसान क्वेश्चन है. चलो, that was part 1 of this question. Part 2 of this question is the least number of carbon atoms required for an alkane to exhibit chirality is. Alkane बोलो तो very simple alkane, only carbon and hydrogen, no saturation whatsoever. तो बताओ, if you have only an alkane, what is the minimum number of carbon atoms required for it to exhibit chirality? What do you think? Let's think about it. We need to make an asymmetric carbon using just carbons. एक तो hydrogen डाल देते हैं इस पे. Let's put a CH3. Let's put another group which is different from CH3. So what can that group be? C2H5 और क्या ही होगा? I think this is the case. I can make an asymmetric carbon only in this configuration. There is no other way to do it. Yeah. So this is your carbon, this is your hydrogen, this is one more carbon, 2 carbons, 3 carbons. So this is the asymmetric alkane. Can there be any smaller asymmetric alkane? If there is some, tell me. Again, Ritesh is saying add deuterium, protium. Alkanes mean carbon and hydrogen only. No deuterium, no tritium. Okay. So Ritesh, interesting idea that you are telling me, but the concept of an alkane is there is only carbon and hydrogen, no degree of unsaturation, nothing. Very simple alkane I have to take. So 1, 2, 3, 4, 5, 6 and 7 carbons are required at least for an alkane to be optically active. Okay? So Ritesh, I hope you understand why we are not using deuterium and tritium as the substituents, because then we can't call them alkanes. Alkanes only have carbon and hydrogen in specific. Chalo ji, nice question. Let's move on to the next one. This is a simpler question. Okay, ये उतना difficult नहीं है. Just have a look at this question. आप देखो इस question को. It's not a very difficult question. काफी simple question है. या क्वेश्चन ही गायब हो गया. अरे भगवान, का चल क्या रहा है इसका. ओके, मैंने कहा खुद क्वेश्चन देखो, क्वेश्चन ही गायब हो गया. सो दिस इज द क्वेश्चन. अच्छा, फर्स्ट क्वेश्चन, देयर आर 2 पार्ट्स नाउ. वंस अगेन दिस क्वेश्चन इज फ्रॉम kinetics. Simple, nothing too difficult, but it will help us revise a few things. Okay, so the first question says half-life of the zero order reaction and half-life for the first order reaction is equal. My dear friends, for 0th order reaction, okay, for a 0th order reaction, what is the half-life? Do you remember the formula? If you don't remember, then you'll have to derive the entire thing. If you want to do that, you can do that. ठीक है, but देखा जाए तो कैसे, अगर derive करना तो कैसे करोगे? A is equal to A naught minus KT. यही होता ना? That is what we have. Yeah, so you put A naught by 2 over here, you will get T half is equal to A naught upon 2K. Yes, for 0th order reaction, half-life is A naught upon 2K. Fine. And you also know that for half-life of the first order reaction, which is also true for all the nuclear reactions, I will get T half is equal to ln 2 by K or 0.693 by K. है ना जी? These are ideas that we know already. Great. तो क्या लिखा है यहाँ पे? If time for completion of zero order reaction is 13.86 minutes. तो ये तो काफी simple हो गया. चलो क्या? So now for the first order reaction, time for completion, it means A is 0 now. There is no A remaining. Time for completion will be equal to, I can say A naught is equal to KT. So time for completion is equal to A naught by K, which is equal to 2 times half-life. So twice the first half-life of the 0th order reaction, your reaction is going to completion. Okay, this T half is the very first half-life of the 0th order reaction. Do you realize that half-life for the 0th order reaction keeps on changing with the concentration of A? Yeah, at any point of time, if I want the half-life of the reaction, let's say the reaction is done. Let's say the reaction is 50% done. At 50% done, now what is the half-life of that particular part of the reaction? It will depend on the concentration of the reactant. But the first half-life of the reaction, which is A naught by 2K, 2 times the half-life is equal to the time for completion. Yeah. So my dear friends, simply I have over here that 2 times T half is equal to 13.86. So T half is equal to 13.86 by 2, which is also the half-life for the first order reaction. This is 0.693 divided by K. So what is K? K कितना आ जाएगा? K comes out to be 0.1 per minute. है ना जी? यहां से आ जाएगा K is equal to 0.1 per minute. करके देख लो. This is what? 6.93. तो k is equal to 0.1 है ना. So this is 0.1 per minute. How do we express it in per hour? This is 0.1 per minute. How do we multiply? How do we make minute into hour? Multiply by 60, divide by 60. Yeah. So I can write it as k is equal to 0.1 divided by 1 minute. Multiply into 60, divide by 60. This is equal to 6 per hour. So the answer to this question becomes 6. Integer type question. Okay. So a lot of you might do it incorrectly, writing 0.1 in the answer. Don't do that. In hours it is being asked. So that's the catch in this question. Okay. In hours you have to do this. 1 minute into 60 is 60 minutes, that is 1 hour. 0.1 into 6 is 0.1 into 60 is 6. So the answer for the first question is 6. So what's the takeaway over here? Take care of the units and try to remember the formula of half-life if you can. Otherwise, if you remember this, you will remember everything. This is the 0th order expanded form. ठीक है, चलो ये हो गया first question. Second question is a little more simple, but again it involves the ideas of your half-life once again. तो क्या लिखा है यहाँ पे? For an acid catalyzed reaction, okay, for an acid catalyzed reaction it says any. For an acid catalyzed reaction, A in H positive going to B, the half-life period is independent of the concentration of A at given pH. If half-life is independent of concentration of A, can I say that this is first order in A? Half-life being independent of the reactant implies that for that reactant the reaction is first order, which we know as a fact already. दूसरा क्या बोला है? At the same concentration of A, half-life time is 10 minutes at pH equal to 2. So let's write down the data. pH equal to 2 बोले तो H positive's concentration when it is equal to 10 to the power minus 2, half-life is 10 minutes. Okay, great. But when the concentration, the pH is equal to 3, that is 10 to the power minus 3, the half-life is 100 minutes. Do you realize what is happening? If my H positive concentration is decreasing, 10 to the power minus 2 is greater than 10 to the power minus 3, yeah? If my H positive concentration is decreasing, yeah, Nishit, we have already done a full chapter series for 2020 students. It's called Let's Revit. Open the playlist, please check it out. भाई जो चल रहा है ध्यान दे ले. So if I decrease the concentration of H positive, my reaction becomes slower. Yeah, I decrease it 10 times, the reaction becomes slower by 10 times. Let's try to investigate. ठीक है, थोड़ा सोच के देखते हैं कि हो क्या रहा है. T half for the 0th order reaction was equal to how much? कितना था ये? This was A naught by 2K. So if my A naught is decreasing, my T half should decrease. But यहाँ पे since A naught is decreasing by 10, my T half is increasing by 10. Yeah? A naught and T are inversely proportional over here. In first order reaction, both are not related at all. Let's try to figure out what's the half-life of the second order reaction. Do you remember the formula? If you don't, you can derive it. अगर करना है तो कर सकते हो derive. But I'll tell you, this is equal to 1 by K times A naught. So my dear friends, if I reduce K naught 10 times, okay, if I do A naught by 10, T half will be multiplied with 10. That's exactly what's happening over here. H positive divided by 10, T half multiplied by 10. है ना, ये डिवाइड किया 10 से, ये मल्टीप्लाई हो गया 10 से. सो कैन आई से दैट दिस रिएक्शन इज सेकेंड ऑर्डर. Okay, this reaction is second order in H positive's concentration. So again, if you remember the formula of half-lives, then life is very easy. Always remember, half-life for first order reaction is proportional to the reactant amount. Half-life of half-life for zeroth order reaction is proportional, half-life for first order reaction is irrelevant, half-life for second order reaction is inversely proportional. ये आइडिया याद रख लो, जीरोथ ऑर्डर में डायरेक्टली प्रोपोर्शनल, सेकंड ऑर्डर में इनवर्सली प्रोपोर्शनल. दैट्स व्हाट यू शुड रिमेंबर फ्रॉम दिस पॉइंट. ओके, सो दिस इज सेकंड ऑर्डर इन H पॉजिटिव, so rate law will be equal to K1 H positive 2 x plus y is equal to 3. So this was a simple question, but I took it so that you could revise the ideas of half-lives of zeroth order, first order and second order reaction at the same time. Nice? Chalo ji, we've already done one thermodynamics question that took 1 hour. Physical chemistry. Chalo आगे बढ़ते हैं. Let's move on to the next question now. This is the last question of take 5 today. So I don't think it's the last, it's the second last question I guess. एक और question पड़ा है. Let's see. ये करते हैं फिर देखते हैं. A strong current of trivalent gaseous boron passed through a germanium crystal decreases the density of the crystal due to part replacement of germanium by boron and due to interstitial vacancies created by missing germanium atoms. Okay, ठीक है, density decrease हो रही है. In one such experiment, 1 gram of germanium is taken and the boron atoms are found to be 150 parts per million by weight when the density of germanium crystal decreases by 4%. Calculate the percentage of missing vacancies due to germanium which are filled up by boron atoms. Very nice question. ये question ना बहुत ही मजेदार है. First we need to understand this question properly, then we can solve this question. पहले आराम से समझते हैं. Kashif is asking, will the series continue till JEE Advanced? That is the plan, bro. We might take a break while your examinations are going on, because while you are giving JEE mains, what's the point of doing this series? Yeah. तो जब exam चल रहे होंगे आपके for those 4 days, we might not do this series, but yeah, before JEE Advanced, I'll pick this up yet again. Anyway, देखते हैं इसमें क्या हो रहा है. So let's try to understand what's happening. See, there is a crystal of germanium. So let's make a lot of germanium atoms. ठीक है, काफी सारे germanium बना लिए अपन. So on and so forth, keep making it. Why am I making this? So that we can understand the question. Now when I pass that boron current, what happens is a few of the places are emptied by germanium. ये भाई चले गए, ये भाई साहब भी चले गए. So I'm creating a vacancy here, creating a vacancy here. Let's say I'm creating a vacancy here. Let's say I'm creating a vacancy here. 1 2 3 4 vacancy बन गई. Let's create 5 vacancies just for the sake of it. Okay, so while passing that current, some vacancies are created, and then now in some of the vacancies, okay, not in all of the vacancies, in some of the vacancies, beryllium comes and sits. यहाँ पे भी आगे बैठ गया मान लो, sorry, not beryllium, boron, चलो B. In some of the vacancies, boron comes and sits there. ठीक है. So my dear friends, over here can I say that boron occupies 2 out of 5 vacancies? Can I say this? Can I say 40% vacancies are being occupied by boron? Yeah, बोल सकता हूं ना मैं. Do you understand? 2 by 5 vacancies are being occupied by boron. 40% of the vacancies are being occupied by boron in this particular case. That's exactly what we need to calculate over here. ठीक है, ये तो बहुत सिंपल सा बता दिया मैंने. Now this is the question. 1 gram of germanium is taken, okay, and then the experiment is done on it. From that, what happens is that boron atoms are found out to, at the end, to be 150 parts per million by weight. Parts per million by weight, okay, when the density of germanium crystal decreases by 4%. Interesting. So then, so after that, you have to calculate the percentage of missing vacancies due to germanium which are filled by boron atoms. Percentage of vacancies filled by boron atoms, that is what you have to calculate over here. Something like this. Okay, did you understand the question? If you understood the question right, understood. Okay. If you understood the question right, understood, then I will try to solve it for you. काफी मजेदार गंदा सा कैलकुलेशन है, करते हैं. This example is given, that's exactly what we have to calculate over there. करना वही सब घटिया. ठीक है, चलो. Okay. Vaibhav and Kavya, can you tell me what's the problem? Savita, can you tell me what's your doubt? How to solve the question that I will teach. But did you understand the point of the question? The question is asking, lots of vacancies are created, some of them are filled by boron. How many vacancies are filled by boron? What percentage of vacancies is filled by boron? Over here it is 40%. We'll try to figure out in the question how much is filled by boron. So chalo ji, let's get ready. Physical chemistry ganda question hota hai. I have reduced the size of the question so that I have space to solve it. ठीक है, चलो कोशिश करते हैं कि यही solve हो जाए. I'll try to solve it here only. If I need more space, I'll move on to the next page. So my dear friends, first assumption that we need to take, okay, first assumption or first hint that I'll give you, okay, hint is density is equal to mass upon volume. What we can assume over here in that image that we had drawn, this was the entire volume. Was the volume changing? No, because the entire crystal is still intact. है ना, crystal पूरा अभी भी intact है. There are just some vacant spaces over there. So for the entire crystal, okay, for the entire crystal, I can assume that volume does not change. See, the crystal will still be a rigid structure. From the crystal, from the inside, you've taken one atom away, two atoms away, three atoms away. Yeah, do you understand? Okay. So it's like this. You have a wall. Okay, you have a wall of bricks. ये पूरा दीवार है. इसमें you have lots of bricks. क्या मस्त घटिया diagram बनाएगा मैं अभी. Yeah, these are bricks. Okay. Let's say you take out 2 bricks. The density of the wall is changing, the strength of the wall is changing, but the overall volume of the wall is not changing, right? Because you've taken away the bricks from the middle. So that's what you're doing over here. The change in density is because of the change in mass. Okay? The change in density is not because of the change in volume, it is only because of the change in mass. So my dear friends, can I say that change in density is as good as the change in mass? That change is how much? 4%. So my dear friends, initially I have taken 1 gram of this crystal. Finally, what do I have? Finally, I have only 0.96 grams of the crystal. Do you agree? Initially, I had 1 gram of the germanium crystal. उस पे experiment किया, सब कुछ हो गया. So initially, I had 1 gram. Finally, I have 0.96 grams. Okay. ठीक है. So how is this reduction happening? Now it's the time for us to figure out how is the reduction happening. So 1 gram minus, okay, minus the weight of germanium atoms removed. So let us assume, say, X, yaar, ghatiya board. Say X is equal to number of germanium atoms removed. Okay. So what will be the mass of germanium atoms removed? Mass will be equal to X into mass for 1 atom. Now the weird thing over here is that this is 72.6 grams per mole of atoms, isn't it? This is 72.6 grams per mole of atoms. So X into 72.6 तो नहीं लिख सकता मैं. I can't write 72.6 directly. 72.6 is the weight for 1 mole of atom. So what is the weight in grams for 1 atom? Divided by 6.022. इतना बड़ा नहीं लिखते चलो. Divided by Avogadro's number. ठीक है. Mass of germanium atoms that is removed is equal to X into 72.6 divided by Na grams. Fine. At the same time, let's say, okay, say Y is the number of boron atoms added. Let's say Y is the number of boron atoms that is added. So my dear friends, once again same idea. I can say that the mass of boron atoms is equal to Y into 11. 11 is the weight given over there, you can read. 11 divided by Na grams. So my dear friends, over here can I write 1 minus mass of germanium removed, that is equal to x. यार घटिया board, आराम से, can't write fast on this, I have to write slowly. So 72.6 divided by Na plus Y into 11 divided by Na is equal to 0.96. Can I say this? ये बोल सकता हूं मैं? Isn't that obvious? 1 minus removed plus added is equal to final weight. So from this idea, if I move 1 over here, it becomes 0.4. So can I say, okay, 1 को मैं दूसरी साइड लेके जा रहा हूं, ठीक है? This is equal to minus 0.04. ये लिख सकता हूं मैं. अब माइनस साइन है, so let's just convert everything into a plus sign. ठीक है, ये प्लस साइन बन जाएगा and this sign at the middle will turn into a minus sign. This is one expression I have. Yeah, this is one expression I have right now, that x plus 72.6 divided by Na minus y into 11 by Na is equal to 0.04. Do you agree with me? इतना तो मैं बोल सकता हूं. ठीक है, ये मैंने प्लस लिख दिया यहां पे, सॉरी, एक्सीडेंटली. x इंटू आएगा. चलो बढ़िया, ये आ गया मेरे पास एक आइडिया. काफी जोर लग गया इसको करने में. This is one idea that we have. Eventually अपने को क्या निकालना है? We need to calculate the percentage of missing vacancies due to germanium. See, vacancies, total vacancies are x. Vacancies occupied are y. This is what we have to calculate at the end. End में अपने को y by x निकालना है. Can you calculate y by x? Y by x calculate कर सकते हो. I think from here itself it is easy to calculate y by x. थोड़ा सा divide कर दो, आंसर आ सकता है. There is a possibility of calculating y by x from here. No, not really. Because if I divide by x, this will become 1, this will become y by x, and this will become 0.04 by x. So we need some more information about one of these, है ना? किसी एक चीज के बारे में थोड़ी ज्यादा जानकारी मिल जाए तो बेटर है. अच्छा, तो this is one statement. Let's keep it at the side. One more thing that is given to us is boron atoms are found to be 150 parts per million by weight. Boron atoms are found to be 150 parts per million by weight. So my dear friends, इसको हटाते हैं यहाँ से थोड़ा. Okay, ये चीज जरूरी है अपने पास. Mass of boron is this much, but this particular quantity is given to us in a different manner as well. This particular quantity I can write it in a different manner. कैसे लिख सकते हैं? Let's try to figure it out. So what's given over here, that in 1 gram of the entire crystal I have 150 into 10 to the power minus 6 grams of boron. 150 parts per million, million is 10 to the power 6. So this is what is given. In 1 gram I have 150 into 10 to the power minus 6 grams of boron. So in 0.96 grams of crystal, which is what we have eventually, I will have 0.96 into 150 into 10 to the power minus 6 grams of boron. This is the weight of boron. This is also the weight of boron. My dear friends, can I write y into 11 by Na is as good as 0.96 into 150 into 10 to the power minus 6 grams. है ना, ये बोल सकता हूं ना मैं. सो दिस पर्टिकुलर वैल्यू कैन बी सब्सटीट्यूटेड ओवर हियर एंड दैट विल गिव यू द वैल्यू फॉर x. डू यू गेट द आइडिया? दिस पर्टिकुलर वैल्यू, दिस मास ऑफ बोरॉन, दिस इज व्हाट मास ऑफ बोरॉन है ना, मास ऑफ बोरॉन दे रखा है, वो सब्सटीट्यूट कर दो यहां पे तो आ जाएगा. या कर डाल दो यहां पे. तो 2-3 चीजें कैलकुलेट करनी बाकी हैं, अभी करते हैं. सो फ्रॉम हियर कैन आई कैलकुलेट y? कैन आई कैलकुलेट द वैल्यू ऑफ y सिंपली फ्रॉम देयर? गंदा क्वेश्चन, बहुत गंदा क्वेश्चन. I don't like so many calculations. But anyway, अब करना है तो करना पड़ेगा. So मैं यहाँ से हटा रहा हूँ this thing, minus 0.96 into 150 into 10 to the power minus 6 is equal to 0.04. तो यहाँ से मुझे निकालनी है वैल्यू ऑफ x. अच्छा, ये कितना आ जाएगा? Is this any significant? Let's try to figure it out. 150 into 10 to the power minus 6. This is 4 into 10 to the power minus 2 है ना? 6, 5, 4. काफी insignificant सा नहीं है ये? Let me try to see. हाँ, मतलब ये क्या कर रहा हूँ मैं? 10 to the power minus 2. So can I neglect this value? What do you say? If I have to add it over here, this is a very small value. Yeah, this is somewhere around 0.15 into 10 to the power minus 2 है ना? क्या करना चाहिए इसको neglect? देखते हैं, कोशिश करते हैं. So this value is somewhere around, okay, 0.144 into 10 to the power minus 2. Do you agree with me? Yeah. तो इसको अगर मैं यहां लेके जाऊंगा, I will get x is equal to 4.144 into 10 to the power minus 2. So from here I am getting x is equal to 4.14 to 10 to the power minus 2 into Avogadro's number divided by 72.6. और यहां से मेरे पास क्या आ रहा है? This value we've already calculated. ये वैल्यू कितना आ रहा है? Is equal to 0.144 into 10 to the power minus 2 है ना? तो y is equal to 0.144 into 10 to the power minus 2 into Na divided by 11. So अपने को करना है y by x करना है. So this divided by this है ना? That is the calculation that we have to do. If I am doing anything wrong, please correct me. थोड़ा flow में हो सकता है मैं गलत कर दूं. So we have this divided by this. Na से Na कट गया, 10 to the power minus 2 से 10 to the power minus 2 कट गया. So I have 0.144 divided by 11 divided by 4.14 divided by 72.6. And if you have to calculate the percentage, just multiply this into 100. So I can write this as 0.144 upon 11 into 72.6 divided by 4.14. क्या ये सही हो रहा है? Am I doing something correct? या इसका परसेंटेज निकालना, सिंपली मल्टीप्लाई दिस इनटू 100. सो ऊपर 14 ला दो सीधा. या लेट्स ट्राई टू डू द कैलकुलेशन. 14.4 इनटू 72.6 divided by 11 by 1.14. क्या मिस किया अपन ने? Did I miss something? हाँ 0.0144 है ना. हाँ सॉरी. ऐसा आएगा क्या? दैट्स व्हाट यू आर सेइंग? हाँ, ये मैंने गलती की यहाँ पे. सो आई थिंक ओवर हेयर एज वेल आई हैव टू करेक्ट इट. दिस शुड बी 4.0144. सब जगह मैं करेक्ट कर देता हूँ. हाँ, तो यहाँ पे भी आ जाएगा 4.0144. ठीक है. हाँ, तो यहाँ पे भी एक करेक्शन 0.0144. ठीक है जी. नाउ इट मेक सेंस, है ना. वो just messed up a power of 10. ठीक है. Now I think it makes sense. So this is the final calculation that you have to do. Percentage निकालना है. This into 100. Answer will be somewhere around 2.3%. मेरा आंसर याद है मेरे को. I remember the answer. So if you calculate this in percentage, this will come out to be 2.3% approximately. Tall question. Yeah. अरे यार, ये मैंने फिर भूल गया इधर. 0.0144. ठीक. 2.3%. Cool. Just one mistake in power of 10. That very sorry for that. But yeah, I hope you understood the methodology of this particular question. Methodology is what matters a little more. हाँ, वही हार्दिक. I did that 10 का घपला. I corrected it now. Yeah. तो चलो, that's it. Let's move on to the next question, which is from organic chemistry. So this is something that I can easily do. Okay. Physical chemistry में I am always bad with calculation. I'll try to improve. चलो, ठीक है. So first case is you have addition to a double bond. ठीक है. So इसके बारे में सोचते हैं. Let's think about it later. That's the question that I wanted to talk to you about. Rest of them are very simple. Chlorine light, free radical halogenation. Pretty much. Is there a rearrangement? No. Is there a carbocation? No. Is there a cyclic transition state over here? No. Over here what's happening? CH3OH and heat. So people, can you see what will be the reaction mechanism? So first we have this guy. Bromine is leaving as the leaving group. You are getting a carbocation which is undergoing a methyl shift. So this is something that's happening. After the methyl shift, you are doing the elimination. Okay? So this guy has a carbocation intermediate and there is a rearrangement that is happening. So Q and P will be true for option number C. For option number D, what's happening? Once again carbocation intermediate, I believe. Yeah, carbocation intermediate बन रहा है. तो यहाँ पे पहले बनेगा आपके पास ये वाला carbocation. Yeah, this guy will rearrange, hydride shift to become the 3-degree carbocation, and then you will add the OH group onto that carbocation. So once again carbocation reaction mechanism, and there is a rearrangement. My question is, what about the first case? What is the correct answer for the first case? Karthikeyan is asking, can we expect these type of questions in NEET? NEET will be very easy. This is just super advanced level so that all of our brains are trained to the full extent. Okay. A का बताओ क्या होना चाहिए? देखो जी, A में I hope you remember whenever you have an alkene, okay, when you add it to let's say Br2 or Cl2. चलो थोड़ा और अच्छी handwriting लिखता हूँ. Let me try. Okay. Dinesh is saying in C, why not E2? Bro, if you do E2, then this product will not be found. That's why. Okay, you can't do E2. E2 होगी तो बाहरली साइड होगी. यहाँ पे हाइड्रोजन ही नहीं. Do you see? There's no hydrogen over here on this carbon. Providing heat, CH3COH. It's not a strong base, it's a weak base. All the hints are pointing out to an even reaction mechanism. Okay. So yes, you are giving me the correct answer. But I wanted to clarify something. ठीक है, मेरे को एक चीज clarify करनी थी, which I was studying today. What we do is we make an alkene, something like this, yeah, and we say that if we add Cl2, okay, the alkene will move on one side, chlorine ऐसा move करेगा, ये वो, you will remove Cl negative. What we say is we form something like this, or bromonium ion. Yeah, there could be bromine in place of the chlorine as well. So this is known as your chloronium ion. Yeah. Now, at least in our Indian education system, most of the times, I'm pretty sure in every class that you've seen for organic chemistry, we call it a non-classical carbocation. Yeah, it's a cyclic halonium ion. Yeah, that's the correct method of talking about it, cyclic halonium ion. But sometimes we call it non-classical carbocation. My dear friends, the thing is, over here carbon does not have the cationic part at all. It is just a chloronium ion. It's a halonium ion. Bromine and chlorine can show this type of a cyclic cation. Iodine can also show, but it's a bit too huge to do a good overlap with carbon. So chlorine and bromine are pretty optimum for this. We sometimes call it a non-classical carbocation, but technically speaking, if we go into perfect technicalities, this is incorrect. Okay, we should not call it a non-classical carbocation. So the question is, what are carbocations? Okay, so answer to aa gaya aapke paas. This is not a carbocation. Don't think that it is a carbocation. The answer is simply S. Okay, so the answer to this match the column is simple. Don't think about it as a carbocation, even if we call it a non-classical carbocation. Let me show you what actually non-classical carbocations look like. I have a very beautiful web page that I've taken for you. दिखाता हूँ आपको. एक सेकेंड. This is a just a second, okay? ये देखो. So this is a web page, chemistrystackexchange.com. What is a non-classical carbocation? And this is your classical carbocation where you have a vacant orbital and there is a positive charge. But there are multiple examples of non-classical carbocations. Okay. There are many examples of non-classical carbocations, but the 2-nor-bornyl carbocation is among the best known. So this is a non-classical carbocation, okay? The carbocation exists over here, but apparently it is more stable than usual. Why? Because it keeps on flipping like this, okay? Carbocation keeps on exchanging its place like this. So overall, this is what it looks like. There's a sort of a delocalization over there. Yeah, when you make the products, you can get the products from both the derivatives. So that's what tells you that both the forms exist. Okay. So labeling experiments have shown that the positive charge resides on more than one carbon in the 2-nor-bornyl ion. Okay. So you can read it up later. Anyway. So there is one more example of a non-classical carbocation. This one. Okay. Carbocation यहाँ पे है on this particular carbon, but the double bond helps that carbocation be better. So in a non-classical carbocation, okay, the idea is that I'll come back to the normal screen. You can search for this on Google if you want. Just search for what is non-classical carbocation. Chemistry Stack Exchange, the web page will open. So technically speaking, in a non-classical carbocation as well, the cation is still on carbon. It might not be on just one carbon. It might be delocalized on 2 or 3 carbons. That's the idea behind a non-classical carbocation. But that's what the case is. Okay, it's not a classical carbocation. That's the only difference. Over here, we do call it a non-classical carbocation. Even when I've learnt about it, we were taught that it's a non-classical carbocation. Everyone teaches it as a non-classical carbocation. But apparently today we've learned that technically speaking, that's not the correct nomenclature for it. Interesting. Yeah, so we should not call it a carbocation because the carbon doesn't have a charge on it. So this is a cyclic halonium ion. From today, we won't call it a non-classical carbocation. Interesting piece of information. That's why I kept this question over here. So now, my dear friends, the next question, this one, it's a good question, not very difficult, not very easy, from your organic chemistry, stereoisomerism. Okay? So this is your homework question. We are done with today's take 5. Although we have done multiple questions, we've clubbed it into 5 different sections. Anyway, so this is your homework question. Answer in the comment section down below. And yeah, today's class is technically over. If you want to leave, you can leave right now. Thank you so much for joining. If you enjoyed the class, hit that like button. I will chat with you guys for 2-3 minutes if you want me to. And that's all. Bharat is saying boards में cyclic halonium लिखा तो marks मिलेंगे? हाँ मिलेंगे, definitely मिलेंगे bro. Okay, definitely मिलेंगे bro. Karthik is saying, tell me the best book for practicing MCQ for NEET. Cengage. Okay. Kratika, thank you. Kratika is congratulating us for 70k subs in advance. Congratulations to you as well. All of you are a very, very, very integral part of the Catalysis family. So, heartiest congratulations to you. We are growing, and let's hope the growth keeps on growing. Yeah. Ishita, I'm not going to tell you the answer right now. Gokul Ram is saying, can I clear JEE mains in 4.5 months? If you put enough efforts, then yes, it is quite possible, bro. How did B create more vacancies than it actually? See, vacancies were created. देखो metallic structure था वो. That was not a charge structure. So it's not that you have to balance positive charge with negative charge. Vacancies were created because some germaniums went away. Boron saw some places, some borons went there. Most of the places were still kept empty. Do you understand what's going on? Yeah. So it's like this. Yeah. Again, I'll give you that wall example. You have this huge wall. Okay. Over here, I've created like 1, 2, 3, 4, 5 vacancies. Okay. Let's say I've created 5 vacancies. Then you come here. You're like, oh, I have space to keep my ball. So you keep a ball over here and you go away. Yeah, you have a space to keep your bat. तो bat भी यहाँ रख देंगे चलो घटिया सा bat बना दिया मैंने. Yeah, so you keep your bat here, you keep your ball here, you will leave 3 vacancies and you go away. That's exactly what boron is doing. It just occupies few of the vacancies and doesn't occupy all of them. Yeah, Vasanti is saying thermodynamics, which book to refer to? NCRT is pretty good for that. Anyway, I'm going to start thermodynamics tomorrow. Anirudh, so non-classical carbocation mein one carbocation is in a very interesting fashion delocalized over more carbons, not other atoms. Okay, so it still is a carbocation. It does not look like a classical carbocation. The web page that I showed you, you can Google it out. Just search for what is a non-classical carbocation and search for the web page by chemistry stack exchange. You'll get the answer over there. ठीक है. Last week's strategy for JEE, Raja, don't take a lot of stress. Whatever you have learnt already, you've learnt already. You can't really learn anything new. So just be confident in yourself, keep practicing. We are doing these sessions so that you stay in touch with your question solving abilities, and eventually I'm pretty sure all of you will do amazing in the final examination if you stay confident and calm. What to do day before the examination? Don't do anything specific. Yeah, बस chill मारो, थोड़ा बहुत मन में revise करो जो करना है, sleep, eat well, go and give the examination. Because in one day, I'm pretty sure no one will be able to learn anything new. Nayanthara is saying, are these previous year JEE advanced questions? Not really. These are a plethora of questions that I'm taking from some or the other study material. ठीक है, so कहीं ना कहीं से उठा रहा हूँ. These might be previous year, they might not be previous year. Most likely they are not. I mean, JEE में भी इतना ज़्यादा complicated नहीं पूछा जाता in advanced as well. Anyway, people, that's it from my side. Thank you so much for joining in. I hope you enjoyed the class. If you are new to the channel, check out the playlists of our channel. There are loads of good things happening over there. And yeah, that's it from my side. Hit that like button, stay subscribed. I will see you very soon tomorrow with yet another episode of Take 5. Good night.